Good morning, student. We have started chapter number 8, Quadrilaterals. Now it is part number 2. In part number 1, we have discussed some property related to quadrilaterals and also types of quadrilateral. We have discussed angle sum theory in part number 1. Now we are going to talk about some theorems from this chapter, and that may be asked in exam, some important theorem, and also some properties based on this theorem that we are going to study here. Now, in this lecture, that we are going to study the properties of parallelogram. In this chapter, we only just discussed the properties of a parallelogram. Now, that how can we say that given any quadrilateral is a parallelogram? For that, we just see here theorem number 8.1. Here given theorem number 8.1, that is a diagonal in a parallelogram. A diagonal of a parallelogram divides it into two congruent triangles. It is very important theorem in this chapter, that theorem number 8.1 may be asked, then we have to prove it. A diagonal of a parallelogram divides it into two congruent triangle. Means here you can see that given that ABCD parallelogram means that opposite sides are parallel to each other. This pair is also parallel to each other, and this pair also parallel to each other. So it is known as a parallelogram. Now let we draw one diagonal AC. Then we are going to prove that here you can see two triangles, triangles ADC and triangle ABC. So these two triangles are congruent, that we want to prove. So let proof of this theorem. Proof, let ABCD be a parallelogram and AC be a diagonal. As you can see in the figure, observe that the diagonal AC divides parallelogram ABCD into two triangles. As you can see here, namely triangle ABC and triangle CDA. That you can see here. We need to prove that these triangles are congruent. We need to prove that these two triangles are congruent. For that, in a triangle ABC and triangle CDA, not that BC is parallel to AD. BC is parallel to AD. As you know that the opposite sides are parallel in parallelogram. So here AD and BC are parallel and AC is a transverse. In that manner, we can say that AC is a transversal. AD and BC are parallel. Then you can say that AC is a transversal of these two parallel sides. Hence, angle BCA, so that angle BCA equal to angle DAC. This angle and this angle are equal. Why? It is a pair of alternate angles that we have already studied in standard 9, that a pair of alternate angles are equal if there is given that two parallel lines and one transversal. Then we can say that angle BCA and DAC are equal, as that are pair of alternate angles. Also you can see that AB and DC are parallel. AB parallel to DC. You can see that AC and DC are parallel and AC is a transversal. So angle DCA and angle BAC are equal. So angle BAC equal to angle DCA are equal, pair of alternate angles. And here AC is common side in both the angle. Triangle AC is a common side in both the triangle. AC is equal to CA, common. So that by the SAS rule, angle side angle congruence rule, by that rule we can say that both the triangle are congruent. Then triangle ABC congruent triangle CDA, that means both the triangles are equal. So just that we wanted to prove that, or diagonal AC divides parallelogram ABCD into two congruent triangles ABC and CDA. Hence we can prove that by using congruence rules. So it is very important theorem that we not here. Now theorem number 8.2, it is given that in a parallelogram opposite sides are equal. In a parallelogram opposite sides are equal. That we have proved in theorem number 8.1 that two triangles are congruent. If AC divides, it is a diagonal of ABCD and it divides it in a two equal or two congruent triangles, then by that way we can say that you have already proved that a diagonal divides the parallelogram into two congruent triangles. So that can you say about the corresponding parts, say the corresponding sides they are equal. That means AD, that means AD is equal to DC and AD is equal AB is equal to DC and AD is equal to BC. In that means we can say that in a parallelogram opposite sides are equal. Theorem number 8.3, if each pair of opposite sides of quadrilateral is equal, then it is parallelogram. It is a converse of theorem number 8.2. It is converse of theorem number 8.2. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That we can prove by, here you can see that ABCD given that parallelogram. Here given that if each pair of opposite sides of a quadrilateral is equal, here AB and DC are equal and AD and BC are equal, then it is a parallelogram. Then we want to prove that it is a parallelogram. By that way, here you can see that if we draw AC diagonal AC, then AC divides in a two congruent triangle, as we have proved in theorem number 8.1. So we can by that way, here AD is congruent to AD is equal to BCA and AB is equal to DC and AC is a common for the both triangle. So SSS rule, we can say that both the triangles are congruent. In that sense, let sides AB and CD of a quadrilateral ABCD be equal and also AD is equal to BC. Draw diagonal AC. Clearly triangle ABC congruent to triangle CDA as congruence rules. So angle BAC equal to angle DCA. BAC, here BAC equal DCA and BCA equals DAC, congruence rule. You have just seen that in parallelogram each pair of opposite sides equal, and conversely if each pair of opposite sides of quadrilateral is equal, then it is a parallelogram. By that way we can conclude that if there is given any quadrilateral and opposite sides are parallel and equal, then it is known as a parallelogram. Or conversely we can also say that in a parallelogram the opposite sides are equal and parallel to each other. Now theorem number 8.4, in a parallelogram opposite angles are equal. If you take the figure as you can see here, and if you measure the angle, opposite angle, then you can realize that the opposite angles of a parallelogram are equal. So we assume that in a parallelogram opposite angles are equal. So here angle B and angle D are equal and angle A and angle C are equal because those are opposites angle in a parallelogram. So it's converse that if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. So one more thing that we are going to remember, that if in a parallelogram the opposite angle are equal, and if there are given that in any quadrilateral their opposite angle are equal, then it is known as a parallelogram. That we are going to assume here. It is one more property of parallelogram. Let us discuss other properties. Theorem number 8.6. The diagonal of a parallelogram bisect each other. The diagonal of a parallelogram bisect each other. Here you can see that we have drawn ABCD, that it bisect or it intersect at O. AC and BD diagonal intersect at O. So let there is yet another property of parallelogram. Let us study the same. Draw a parallelogram ABCD and draw both its diagonal intersecting at point O, as you can see here. Measure the length of OA, OB, OC and OD. OA, OB, OC and OD. OA, OB, OC and OD. This length. What do you observe? You will observe that OA and OC are equal and OB and OD are equal, or O is a midpoint of both the diagonal. In that manner we can say that O is a midpoint of both the diagonal. Repeat this activity with some more parallelograms. Each time you will find that O is the midpoint of both diagonals. So one more property that we are going to remember, that the diagonal of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. Means it both are divides each other in two equal parts. After that, theorem number 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. It is a converse of theorem number 8.6. You can reason out this result as follow. Note that in figure, as you can see here, it is given that OA and OC and OB and OD are equal. Given that inner diagonals of quadrilateral bisect each other, that means it divides each other in two equal parts. Means OA equal to OC and OB is equal to OD. Now you can see here triangle AOB and triangle COD. Here you can see that in triangle AOB and triangle COD. We just want to prove that DC and AB are equal. And from one property, we can say that AB and DC are equal, then it is a parallelogram. So here, therefore, angle ABO equal to COD, vertically opposite angle. Why? It is a vertically opposite angle. It is a vertically opposite angle. So AOB and COD are equal. From this we get AB parallel to CD. AB parallel to CD. Similarly BC parallel to AD. Therefore ABCD is a parallelogram. One more property. Theorem number 8.8. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. That in a parallelogram, there one pair of opposite sides is equal and parallel, then we can say that the given quadrilateral is a parallelogram. Look at the figure in which AB is equal to CD and AB is parallel to CD. Let us draw diagonal AC. You can show that by the diagonal you can show that it is it divides in a two equal triangle ADC and ABC. From that here you can see that DCA and BCA are equal because it is a alternate angles when, and also AD and AB, DC and AB are equal as the given here, and AC is a common for both triangle. So easily you can prove that triangle ABC is congruent to triangle CDA by SAS rule. S angle, S means side, SAS rule. You can say that triangle ABC is congruent to triangle CDA, so that BC is parallel to AD. So we can say that. Now one more theorem, the midpoint theorem. The midpoint theorem. Let us draw a triangle and mark the midpoint E and F of two sides, any two sides of a triangle. We are going to take midpoint of two sides, and here you can see that you can find ABC as a triangle. So E is a midpoint of AB and F is a midpoint of AC. We just joined E and F. E and F. Join the point E and F. Measure EF and BC. EF and BC. Measure angle AEF and angle ABC. ABC. What do you observe? You will find that EF is the half of BC. EF is the half of BC. And angle AEF is equal to angle ABC. AEF is equal to angle ABC. If these two angles are equal, then you can say that EF and BC are parallel to each other. Parallel to each other. So EF and BC, EF is parallel to BC. Repeat this activity with some more triangles. So here we can conclude that one theorem or a midpoint theorem, that if we join one line segment from midpoint of two sides, then it is a parallel to third side. If we draw line segment from midpoint of two sides, then this line segment is parallel to third side, and also it is the length of this line segment is half of third parallel side. So by that way, we midpoint theorem that we are going to prove here. Theorem number 8.9. The line segment joining the midpoint of two sides, the line segment, that is this one line segment joining the midpoint of two sides E and F of a triangle is parallel to the third side. It is parallel to third side, that we are going to prove here. You can prove this theorem using the following clue. For that, let me draw one line from a vertex C, and it is parallel to BE. It is parallel to BE. And let me extend EF to D, intersecting this line. So here EF and CD is parallel. Observe figure in which EF are midpoints of AB and AC respectively, and CD is parallel to BA. CD is parallel to BA. We draw on one line, CD is parallel to BA. Now easily a triangle AEF and triangle CDF are congruent by SAS rule. By SAS rule. Because here BC, BA and CD are parallel, then you can say that this angle BAC and DCA are equal, because it is a alternate angles. And also EFA and CFD are equal. Why? Because it is a vertically opposite angle, and one this side FAF and FC are equal because F is the midpoint of these angles. So by the congruence theorem, angle side angle, angle side angle rule, we can prove that both the triangle AEF and CDF are congruent. By that way, EF is equal to DF, then we can say that EF is equal to DF, BE is equal to AE, BE is equal to AE, AE, BE is equal to AE, and EC, it is equal to DC. It is equal to DC because A is equal to DC. Means here BE is equal to क्या हो गया? DC is given. Then therefore BCDE is a parallelogram. This gives EF parallel to BC. If it is a parallelogram BCDE, because BE and CD are equal and parallel, then we can say that this one is a parallelogram. So BCDEF is a parallelogram. Then we can say that EF is a parallel to BC. That we wanted to prove. This gives EF parallel to BC. Then it is midpoint, that if the line segment joining the midpoint of two sides of a triangle is parallel to the third side. And also we conclude that this line segment is a half with half of the parallel side BC. EF is half of ED, EF is half of ED, and also EF is half of BC. It is known as a midpoint theorem. Now last theorem, theorem number 8.10, the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. It is converse of. Just we can assume that in the figure 8.26, observe that E is the midpoint of AB. Line L is passing through E and is parallel to BC, and CM is parallel to BA. As you can see in the figure, we can also prove it by, as we have done in the theorem number 8.9. So we just assume this theorem, midpoint theorem. If line segment joining the midpoint of two sides, then this line segment is parallel to another side, and also the length of this line segment is half of the parallel side BC. Now write all the theorems 2 times and try to remember it. And related to this theorem, there may be asked some one-liner or MCQ type question related to the properties of parallelogram. Just remember all the properties and write it 2 times.